Hello folks, welcome to the Night Sky Imaging YouTube channel, and today we're going to revisit the Spectrophotometric calibration tool, and I want to show you a comparison that I did that got me to thinking, which isn't always a good thing. Okay, so on December 1st we had some so-so skies and a moon that was about it was annoying. It was far from being full, but at any rate, let's go to okay. I took two different runs of images stacked for the Pleiades M45. I used a RASA and only exposed for 15 seconds, and in the first run, I did not use a UV IR cut filter. I used a one-shot color camera, and I used the generic sensor as recommended by PixInsight in their documentation when running the Spectrophotometric calibration tool. So this is what I got. And let's unstretch the channels first. So there's quite a bit of light pollution gradient that was created, and that's annoying to me. It's not part of this video, but I'm going to deal with some of that. So I'm going to run see if that helped any. Yeah. Let's run it one more time, this time using subtraction. And take a second. Got to run the execute. Okay, I knew that, but do that all the time. All right, well, it got rid of that. So I still have light pollution issues, but it's what it is. So I did not use any kind of a blocking filter. So this is the camera sensor exposing for the Pleiades. Now, I want to bring up the spectrophotometric calibration tool, which you can find under processes, all processes. And if you've updated your PixInsight, you'll find this tool's been added. And if you've added the Gaia catalog, if you haven't, you need to watch the prior videos on how to do that. So I've already saved a process that has my sensors, but I am now using an IR UV cut filter because it's recommended in the documentation in order to render the best color. But it also makes sense that if you have moon issues or light pollution, that you use some kind of an IR UV cut filter anyway. But in this case, there isn't any. And I also used the recommended by PixInsight documentation, the ideal QE curve. And this is the curve created when you have a perfect sensor because it covers the whole entire spectrum and represents it like an ideal camera would. So I didn't have and don't have an ideal camera, I don't think, but there is a way to find out. You can find out when you run this script. So let's run it. The only thing I need to do is I need to create a preview and mostly over background. So let's do that about right there. And from the preview, we're going to pick, okay, so we're good to go. Let's run it. Takes just probably 20-30 seconds to complete the new process, which is in and of itself awesome because the old photometric calibration tool, uh, particularly on a drizzled images when you are drizzling 2 times, which I have to do for my undersampled images, it might take 2-3 minutes. Okay, so let's restretch this image. And here is the issue. You want these representations to go along the linear line. I don't know what you call them, but they're all over the place down here. It curves up and it curves down on the blue side, and it curves up on the red side. So when I first ran this, even mentioning I don't know what that means, but I will ultimately find out. Well, I have found out. So let's just keep that in mind visually. I'm going to run it again, and it won't show 2 versions of this, so I'm going to have to just delete this. I'll go ahead and just delete this. And I want to open up the second run, and that's here. And this is the second stack. Each stack was 100 15-second exposed images. I used the RASA and the 183. Now, I have the L Pro filter by Optilong on this run. And so let's stretch it. And you can see that right out of the gate, the light pollution has been dealt a pretty serious blow. But to be fair in the comparison, I'm going to go ahead and run DBE, the same setup, and I'm going to run it in division, and I'm also going to run it using subtraction. I'm going to do the same exact thing I did on the first stack. All right. This will help even further with the light pollution, or it should. Yeah. So we've removed some of the gradient. I got some weird artifacts up here. Not sure what's going on there, but that's another day. All right. So this was the setup because I did not have an IR UV cut filter. And now that I do, I want to change this to IR UV on all 3 channels. And instead of the ideal QE curve, I'm going to pick the one for the IMX 183 camera, since I'm using the ASI 183 MC camera, which is a 1-shot color camera. I need a preview, and I think I picked one out somewhere over here. So we'll go to the same area, and from the preview, we'll set that, add that to the settings. And so let's go ahead and run it, and let's check this curve out. By the way, these were shot at the same night. It doesn't take long to shoot 100 15-second images, but the moon had, and this is the second run. In the first run, the moon was lower in the sky. The second run, it was higher in the sky. All right, so this is the second run, and you'll notice that all of my data points are falling right on the linear slope where they're supposed to be. And the difference is the IR UV cut filter and the Sony IMX 183. Now, what I didn't do, and had I wanted to spend another 100 shooting another 100 images, and I may end up doing that on a night when I just want to play around, is do another run. And no, I don't even have to do that. Use the QE curve instead of the Sony IMX183 curve and see if there's a difference. I can do that now. So let's close this out. Let's close this out. And let's go back and open up this image again. And let's see. Stretch it. We're going to have to run edges again. Probably shouldn't have done that in the first place, but we'll get rid of some of the gradient. And let's do now subtraction. Okay. And stretch it. All right, so we're dealing with the same background. I need a new preview, which is in that neck of the woods. And this time we're going to use the ideal QE curve. And I don't have an exact remembrance of the other curve. I just knew that the plots were all on the linear slope. And let's see what happens here, because I have no idea. It may be the ideal QE curve is okay. And what's important is that you use an IR UV cut filter. We're going to find out. And I have no idea. Okay, well, I do know on the red channel that I was not biased to one side or the other. I need to compare these two, but clearly there is a difference. It's a lot tighter down here. It was tighter down here before as well. I'll have to look at both and compare those two graphs, but at least I'm pretty much convinced that I'm going to be using the sensor that if I have a Sony representation here, then this is what I'm going to be using. And hang on just one moment. Well, just found out my pastor has COVID. So that was why I put you on pause, which you probably didn't know. I lost my train of thought. Oh, I am just going to use the sensor that applies, and if I have a sensor that's not represented here, I'll use the ideal. So that's the big change, and also the difference in the IR UV cut filter, and it does make a difference, significant. So, folks, it's a great tool. It's going to render the most accurate color. Just be careful after you get the accurate color that you don't start making these huge swings and change the accurate color to something that's not accurate anymore. So you can add saturation, and you can perform all of the tweaks and tricks and things in PixInsight to improve your images. But if you want accurate color representation, you got to leave the hue slider alone and avoid making selective color adjustments, or you're going to throw everything out of whack. Isn't that crazy? And that's what we probably all end up doing anyway. But this does guarantee you that you're going to be as close as possible to the most accurate color rendering of your part of the sky that was imaged. So with that being said, guys, I hope you have a great rest of the day. Clear skies in your neck of the woods. Catch you later.